Okay, so now we're on the next page. It says graphing g of x equals the absolute value of x plus k, and g of x equals the absolute value of x minus h inside of the absolute value sign. So we're going to talk about these two functions. It says to graph each of these functions and then compare each graph to the graph of f of x equals the absolute value of x. And we're going to describe the domain and the range, and we're going to create a table of values and then graph them. So the best thing to do here, we're going to create an XY table. So we're going to start over here. We're going to do this one first. So I'm going to create this XY table. And it's always best to choose 5 points. We're going to start with -2, -1, 0, 1, and 2, which is what you did on the Desmos activity. We're going to take these values and we're going to plug it into this equation and solve for y. Okay? So here I'm going to leave this here, and I'm just going to kind of do them up on the side because I know you guys like to see the problems written out. So first one, I'm going to take -2, and I'm going to say if g of -2 is equal to the absolute value of -2 plus 3. Well, the absolute value of -2 is +2. So +2 plus 3 is equal to 5. So g of -2 is equal to 5. And we are going to continue to do this for each of the problems. So g of -1 is equal to the absolute value of -1 plus 3. So g of -1 is equal to 1 plus 3. G of -1 is equal to 4. Okay, next problem. G of 0 is equal to absolute value of 0 plus 3. So g of 0 is equal to 0 plus 3. So g of 0 is equal to 3. Do it again. G of 1 is equal to the absolute value of 1 plus 3. So g of 1 is equal to 1 plus 3. G of 1 is equal to 4. And then the last problem, g of 2 is equal to the absolute value of 2 plus 3, or g of 2 is equal to 5. So if you notice, you should be able to see here that it goes 5, then 4, then 3, then 4, then 5. So once you start to see this repeat pattern in the y, where it goes down and then goes back up, that means that the point that's here, somewhere here in the middle, is where our vertex is, where it starts to change back over from one direction to the next. So now we're going to take our rulers and we're going to create our graphs. So make sure you go get a ruler. They are on the side, on the ledge. Grab one. I'm going to create, if you need to pause it and go grab it, pause it and grab it. I'm going to create an XY coordinate plane. These are just sketches. And what you're going to do now is we're going to now plot these points. So these are all coordinate points. We're going to plot the first one, -2, 5. So I'm going to go down -2. So we're going to -2 and up to +5. I'm going to put a point there. Sorry, I'm crossing off my equation. Sorry about that. The next point is -1, +4. So I'm going to go up to -1, +4. My third point is 0, 3. Go 0 up to 3. My next point is 1, 4. And my last point is 2, 5. So you'll see your V shape. So there's my absolute value function. I'm going to connect these using a ruler. and there's my V-shape graph. And now it says we're going to describe this domain and range. So the domain of this function, I'm just going to bring this down this way a little bit so you could see. So the domain of this function is all the x values to all the y values. Again, the domain here is all real numbers, or negative infinity is less than or equal to x is less than or equal to positive infinity. Same as our parent graph. Our range, though, now, our parent graph's range started at 0 and went all the way up. But this range is starting at 3 and going up. So this range is 3 is less than or equal to y, which is less than or equal to positive infinity. That's my y values. Okay, so now what happened from the parent graph to this graph? So I'm just going to draw what the parent graph looks like. Starts here, goes here, and here, and here, and here. And if I take my straight edge and I connect my points, I'm going to draw this out too. So if you notice, this whole graph moved up. How far did it move up? It moved up 3 units. So the graph, we're going to use big terminology, translated 3 units up. And that's the terms we're going to use. So this graph moved, it translated 3 units up. Okay, let's now look at the second problem. So this one says that m of x is equal to the absolute value of x minus 2. Now this time the minus 2 is not on the outside, it's on the inside of the absolute value symbol. So we're going to do the same process. We're going to create our XY table. Okay, oh, I'm going to move it over, I guess. I guess you can't see that. All right, so we're going to move it over. There's my XY table. And we're going to use the same numbers, -2, -1, 0, 1, and 2. And now we're going to plug it into this equation. So when x is -2, m of x, I don't know if you can see all the way up there. I'm going to move this up a little. All right. So what is m of -2? It's equal to the absolute value of -2 minus 2. That's equal to the absolute value of -4, which is equal to +4. So m of -2 is equal to 4. All right, next problem. Okay, m of -1. -1 minus 2. -3. -3. Okay. M of 0. So I'm still looking to see where this changes over. It hasn't changed over yet. So we're going to keep going. I'm going to try m of 1. Still hasn't changed. Hopefully it's going to change soon. So we're just going to keep going until we kind of see where this pattern is. So I'm going to keep going. So I'm going to plug in 2. So the absolute value of 2 minus 2, 2 minus 2 is 0. The absolute value is 0. And notice it still hasn't gone. So I'm going to keep going. I'm going to add a 3 here. So I'm just going to continue my table down here, okay? XY table. Can't see me. All right, now I'm going to add a 3 because I just want to make sure. If I plug in a 3, 3 minus 2 is 1. The absolute value of 1 is 1. So now I'm starting to see a change. If I plug in a 4, I'm just going to do a couple more points. 4 minus 2 is 2. The absolute value of 2 is 2. So starting to see it starts 4, 3, 2, 1, 0, 1, 2. And then we know it's going to be 5, 3, and so on and so forth. So now we're going to create our graph. So if you don't see the numbers right away, you want to just keep going until you start to notice them. So you can see the change of the absolute value. So I'm going to draw my X and Y axes. Use your ruler. Okay. Okay, and now I'm going to graph my points. -2. Up and down. So -2, +4, -1, +3. That should be -3, +5, -3, -2, +4, -1, +3, 0, 2, 1, 1, 2, 0, and then we continue down here below. 3, 1, 4, 2, 5, 3. So you get the idea. So you can see it starts to make that V shape again. That's what we're looking for. It's not perfect because I'm not using graph paper. So you get the idea. All right, and again, we talk about domain. So the domain of this function is, again, all real numbers. Farthest to the left, farthest to the right. The range is the same as our parent graph, and that goes from 0 is less than or equal to y, which is less than or equal to +infinity. So that's the first example.